20-1s as we continue the world of quadratic equations. So we've talked so far in terms of solving quadratics. We have graphing, okay, with the calculator as a possibility where we see the x-intercepts. The other one we talked about was, well, factoring to identify the x values for the equation. Well, there's going to be two more that we do. Today, we're going to talk about the square root principle or completing the square, which is what we did last unit. There's also one more that we're going to add using what's referred to as the quadratic formula. Now, each method has its pros and cons. There's 4 of them. Graphing with the calculator, well, if a question says solve algebraically, well, algebraic, we know that the calculator's off the table as a choice. It's always a great way to check the work. It doesn't say you can't use your calculator to check, but algebraically, factoring, square root principle, or the quadratic formula, which we'll get to next lesson. So here we go. Let's take a look at this idea of quadratic solutions by square root principle or completing the square. Well, what we saw with the factoring is when you have an x squared value, when we factored, we kind of always ended up with 2 possibilities for x. So we're going to get 2 solutions. However, there are times there will be no solutions. And again, factoring, this process of solve by factoring, well, when can you solve by factoring? When a question's factorable. You're going to get some that are factorable, but not with nice numbers. That's why we have to have other processes. This idea today, the square root principle, the square root principle tells us, and what becomes important is this idea that anytime we are doing work and we square root a value, well, the square root of 9 we think of as 3. But there's another possibility, and that's -3. Because -3 times -3 is +9. 3 times 3 is +9. So when we square root something, we can get 2 solutions, 3 or -3. The positive and the negative is what we get when we square root something. So that's what we're going to have to consider and how we end up getting 2 solutions. Really jumping into a question is the best way. So on page 8, we're looking at this process when you have just an x or an x squared in the equation. We can see there's only one term that has an x, so it's not too difficult. Well, this is about as easy as you're going to see. If x squared equals 9, we want to know what x could be. It all comes down to isolating the x using algebra. How do we isolate the x here? Well, we have to get rid of the 2. In this case, it's a power 2. So to undo squaring something, we square root. Whatever we do to one side, we do to the other. Square rooting x squared leaves us with x. Square rooting 9 leaves us with 2 possibilities, positive or -3. So x is 3 or -3. There's the solution for that equation. If we did a quick verification, well, x squared equals 9. If x equals 3, we would have 3 squared equals 9. And if I do that, yes, left side equals right side. So x equals 3 is correct. If we used x equal to -3, well, I want to substitute in, I want x to be squared. That means I want my -3 to be squared, and it needs to be in brackets because I want all of x, all of negative 3 to be squared, and that should equal 9. And when we do that, 9 equals 9. Left side equals right side. So x equals to negative 3 is also correct. That's about as easy a question as you're going to get. We're going to get a little bit more complicated. X squared minus 17 equals 0. Again, we simply have a single x squared term in this equation, so we need to isolate it with algebra. Note, exact values or rounded values depends on what the question asks for. If it asks for exact values, we've talked about it, you don't want a rounded decimal. If a question tells you to round to a certain place, well, then obviously a rounded answer is acceptable. But what we need to do is isolate the x through algebra. In order to get x by itself, we have to get rid of the 2, we have to get rid of subtract 17, get rid of subtract 17 first by adding a positive 17. Add a positive 17. We then have x squared equal to 17. How do we get rid of squaring something? We square root. We square root. Therefore, in this case, x equals not just root 17, it's the positive or negative root 17. What can I multiply to get 17? Root 17 times root 17, or negative root 17 times negative root 17. So both root 17, negative root 17 are possible solutions for x. These obviously are exact values. That's what you'd have to put if a question asks for exact values. If a question said you could round, well, then you would simply want to square root 17. And if you square root 17, and let's say that it goes to the hundredths place, x could equal to the hundredths place 4 and 12 hundredths, or negative 4 and 12 hundredths. This would be rounded. Depends on what the question asks for as to what you can do. But again, it's all about isolating the x using this square root principle that when you square root something, it's the positive and the negative of it. These questions we can go through fairly quickly because it's algebra with one little twist that's not difficult, hopefully. Here, well, we need to get rid of this subtract 3 and the exponent 2. Because the x minus 3 is in brackets, we want to get rid of the exponent 2, the squared first. So I'm going to square root this whole thing. X minus 3 all squared, but square rooted leaves me with x minus 3. But whatever I do to one side, I do to the other. X minus 3 equals root 25, which is positive or negative 5. Now this is where you have to start to think a bit, because x minus 3 can be two things, so you need to solve x twice. Both ways. Because what do we know? We know that x minus 3 equals positive 5, but we also know that x minus 3 equals negative 5. So we always have to make sure that we're solving for both positive and negative 5. In this case, add 3 to both sides, x equals 8. In this case, for the second one, we're going to add 3 to both sides, and x will equal negative 2. So our roots for this question are 8 or negative 2, because square root principle tells us positive and negative, which means we need to isolate x for positive 5 but we also need to isolate x for negative 5. Now, if we do a quick verification, we want to verify that x minus 3 squared equals 25. Well, the first time we said x was 8. So if we plug this in, 8 minus 3 squared, 5 squared is 25. And that's what we want it to be. Left side equals right side. So x equal to 8 works. Second possibility was x equal to negative 2. Negative 2 minus 3 squared equals 25. In the brackets here, we get negative 5, but it's all in brackets squared. Negative 5 times negative 5 is a positive 25, which we hoped it would, because then left side also equals right side when x equals negative 2. So x can equal 8 or negative 2. Here we go again. 3x squared minus 7 equals 0. Well, we want to get the x by itself, so we're going to add 7 to both sides because it's easy to get rid of that. We're left with 3x squared equal to 7. Well, we have to get rid of the 3. It's attached by multiplication, so we're going to divide by 3. And we get 7/3. So x squared equals 7/3. To get rid of the squared, now we have the square. We square root both sides. So x equals root 7/3, which could be written as root 7 over root 3. Is that the answer? No, because what did we forget? Square rooting leaves us with positive or negative as solution. X is positive or negative root 7/3. So it's positive or negative root 7 over root 3 or negative root 7 over root 3. Now, this way of writing is not acceptable. It is right now. Some of you might come across a question and it doesn't look like this. Well, another way to write this would be positive or negative root 21 over 3. We're going to talk about this in another unit. We haven't done this. Technically, square roots and denominators really aren't acceptable. Eventually, we're going to look at how to write it without it. But right now, these would be acceptable. Always, always square root principle. Once you square root, remember it's the positive or the negative. Let's just keep plugging away. Lots of examples here. It's just some algebra with square rooting in it. Not overly complicated, hopefully. At this point, x squared plus 25 equals 0. We're going to have to subtract 25 so we can get x by itself. But now we run into some problems because if we square root, we're left with x equal to, again, square root principle tells me the positive or negative of negative root 25. Hopefully at this point your spider senses are tingling because you can't square root a negative. It's not allowed. So this here, technically, is not possible. And if you run into math that's not possible, well, in this case, there are no roots. Because you get to math that can't be done, that's saying no roots are possible. So in this case, if we were to visually do it, chances are we're going to have a vertex above the x-axis and we open up, or we're going to have a vertex below the x-axis that opens down. Either of these situations has no x-intercepts. So that's how we end up with a solution of no roots. It just doesn't occur. Well, it looks bigger, looks uglier. Every now and then, I hope you're turning this off and attempting these. Maybe turn off the video, try it, and then we'll talk about it. In order to do this one, to get the x by itself, well, what are we going to have to do? Add 12, because it's the least attached part. We're left with 3 bracket 2x plus 5 squared equal to 12. Well, now we can divide by 3. Divide by 3. We're left with 2x plus 5 squared equal to 4. Slowly, we get closer and closer to isolating our x. Now we have this exponent 2. So we're going to square root and we're going to square root. Square rooting cancels out our squared. We're left with 2x plus 5 equal to, well, we can do the square root of 4, which is 2, but square root principle tells us it's positive or negative 2. So, whole bunch of little algebra steps that really go back to like grade 7, some of them. Square root principle, positive, negative 2. So that means we have to solve x twice. Because we now have 2x plus 5 can equal 2, but also 2x plus 5 can equal negative 2. And that's going to give us a different x in each case. Subtract 5 and divide by 2. One possibility is x equals negative 3/2. And the second one, if I solve it when x, or our root is negative 2, we get 2x equal to negative 7 and x equals negative 7/2. So we get 2 possibilities for x for our equation. Lots going on there, lots of information, lots of steps. Well, we turn the page. When we turn the page, the difference is we now have an x squared and an x. So I can't just isolate x nice and easily at this point. This is where we can start looking at completing the square, which is what we did, is essentially creating the vertex form process. We want to create vertex form for our quadratic equation because that gives us only a single x to work with. So follow along. We already did this and you guys did a great job of it last unit. Let's hope you remember. We bracket x squared and x. We want x squared by itself, so I just have to factor out, in this case, a 1. Leaves us with x squared minus 8x plus 7. Well, now we need to find that special number. Remember, we take the x term, negative 8, we divide it by 2, and we square it. That leaves us with 1 x squared minus 8x, but now we want to add negative 8 divided by 2 is negative 4 all squared. We want to add a 16. However, when we put that 16 in, 1 times 16, we added a value of 16, so we need to subtract 16 to balance that out. What do we get left with? 1 out front, which really isn't necessary. X squared minus 8x plus 16 becomes x minus 4 squared minus, and 7 minus 16 leaves us with a negative 9. There's the form we have so far. And at this point, now we isolate the x. So we had to do all of this work completing the square just so we could get an equation that's a quadratic with a single x. So now I bring it up here, x minus 4 squared minus 9. Got to get x by itself. Add 9 to both sides. Square root to get rid of the squared. Square root principle. Square root of 9 is positive or negative 3, and that now leaves x minus 4. Well, I have two possibilities. 3 could equal x minus 4, or negative 3 could equal x minus 4. At that point, solve for x, add 4, and x equals 7. Here, add 4, x will equal 1. So there's the two possible values for x for our initial quadratic of 0, x squared minus 8x plus 7. All of this complete the square work just so we can get the equation that we then have to solve. Two big questions in one. Now, what's interesting with that solution, we completed the square and then we isolated x. We did that. However, is that a really effective way to do this question? How else can we solve for quadratics? Well, this is where we have to start looking to decide what we can do. We didn't even think of the factoring process we had talked about a couple lessons ago. Well, here's a simple trinomial, a nice simple trinomial. Are there things that we can multiply to get to 7, but add to get to negative 8? Well, what about negative 7, negative 1? We could have simply just done the factoring, and if this equaled 0, x would equal 7. If this equaled 0, x would equal 1. The exact same two solutions, but holy cow, is this factoring process ever quicker and easier. So this is what I said at the start of the lesson. You need to start choosing a process that's effective. Choose a process that works. Oh, you see a simple trinomial? Maybe you can just quickly do that. If it's not factorable, well, then you'll have to do something else. But you need to start taking a second. Can you factor? Because that's a much more efficient way to solve than completing this square and then solving. Lots of steps that aren't necessarily necessary. So here we go. X squared plus 6x minus 2. Well, based on what we just talked about, if we take a look at this, are there two things to multiply to give negative 2, but add to give 6? Let me help you out. No. This one is not factorable with whole numbers, nice and easy. So this is a situation where completing the square does become kind of important. Complete the square, and then once we've done that, then we'll be able to solve by isolating the x. So that's what we have to do. Take a second, stop the tape, give it a try. There's the completed square. Just factored out from our x squared and our x of 1. Magic number, 6x divided by 2, which is 3. 3 squared is 9, so that's what I plugged in. We actually added a 1 times 9, positive 9, so I had to subtract 9 to balance that out. Factor this, x plus 3 times x plus 3, which is x plus 3 squared. Negative 2, negative 9 gives us our negative 11. Now we have a quadratic equation with just a single x Now we can solve it. Isolate, add 11 to both sides. We get 11 equal to x plus 3 squared. From there, we square root, and we square root. Well, square rooting a squared gets rid of the squared. Root 11, let's do an exact value. That's what we should always go to unless it states otherwise. In this case, exact value is 11, but positive or negative 11, square root principle, and that'll equal x plus 3. From there, we need two values because root 11 will equal x plus 3, but also negative root 11 will equal x plus 3. Get x by itself. Root 11 minus 3 is one possibility for x. And in the second situation, to isolate the x, subtract 3, and we get negative root 11 minus 3 equals x. Either is acceptable. Either is correct. If you prefer, you could have negative 3 plus root 11 equals x. You could have negative 3 minus root 11 equals x. And sometimes you will see this written as negative 3 plus or minus root 11. Since we're doing both of those things, equals x. All acceptable ways of writing that answer. But we had to start with this whole complete the square before we could solve. So here we go, last example. And then you're going to have a chance to get some work done. So here we go. Negative 3x squared plus 12x minus 9. Complete the square. Take out a negative 3, leaves us with x squared minus 4x minus 9. Magic number. There's our negative 4 squared, squared. Negative 4 divided by 2 squared leaves us with 4. But we've actually, in this case, put in a negative 12. So we have to take out or put in a positive 12 so they counteract each other. What are we left with? Negative 3. X minus 2 squared plus 3. So 0 equals negative 3, bracket x minus 2 squared plus 3. Now we have a quadratic with just a single x, so now we isolate x. Minus 3, minus 3. Negative 3 equals negative 3. X minus 2 squared squared. Divide by negative 3. 1 equals x minus 2 squared. Square root, square roots. What does this leave us with? Square root principle, positive or negative root 1. And from there equals just x minus 2. Because square rooting the square cancels out. So here's two possibilities, positive or negative 1. So finish it off. We could have root 1 equals x minus 2, or we could have negative root 1 equals x minus 2. Get x by itself, add 2. We have 2 plus root 1 equals x. Second situation, add 2. 2 minus root 1 equals x. Two possibilities for x where we have 2 and then we're adding or subtracting root 1. So a simplified way of writing those two things. 2 plus or minus root 1. That's your x value. So lots of interesting stuff there. From there, you have that assignment, textbook 240, It's a lot of practice of this, isolating the x. Do some practice. Have a great day.